Now let's look at an S1 handover call flow and focus on the security aspects. We will be looking at the scenario where in the previous slides where we are going from eNode B1 to eNode B2 and NH2 has already been sent to the source eNode B in that case during the path switch request. And this is going to be a handover between the source eNode B to the target eNode B, but not using X2, but using S1 going via the source MME. And we'll also consider the case that the MME is also changing. So the target MME is the one that is controlling the target eNode B. And that's typically the case for an S1 handover, is you don't have an X2 interface because this eNode B is being controlled by another MME, which is different from the one that is controlling the source eNode B. And so this is the starting condition from a security perspective. The source eNode B requests the UE to make measurements, and when the UE is at the edge, it provides measurement reports. Based on that, the source eNode B makes a handover decision, and it knows that it needs to hand over the UE to the target eNode B. That's the best cell to which the UE can be handed over to. And it realizes it doesn't have an X2 interface with it, so it does the indirect communication via the source eNode B, and it says there's a handover required. Here is the target eNode B, the target and the target tracking area identity, and it provides what's called the transparent source to target container. So this is information that it's useful to the target eNode B. So you're saying, hey, this is used for my sibling over here. You, the old generation core network, don't need to bother about it. This is not something for you. This is for my generation. So just pass it on to my sibling over there. So that comes to the source MME. Once it comes to the source MME, it knows that this is a handover and it needs to compute a new next hop parameter, which it does from NH2, which is the previous one that it had, and the NCC count is increased to 3. It provides this NCC count over to the to the target MME after it selects one, and it also provides the UE security capabilities to the target MME. Now the target MME will go ahead and provide this NH3 with NCC. So it's basically just turning it around, sending it to the target eNode B along with the transparent source to target container that the eNode B had, source eNode B had sent. The target eNode B will do admission control, will figure out whether it can admit the mobile, does it have the resources or not. Also, on a security perspective, since it's got NH3 and NCC, it knows it needs to do a vertical key derivation based on NH3. So it uses NH3 to come up with K eNode B star, which is the one that it'll be using for communication with the UE when it finally shows up at the target eNode B. It then sends a handover request acknowledgement with a transparent target to source container. But this target to source container actually has the RRC reconfiguration command, which needs to be sent to the UE, just as in the X2 case. And here in the RRC reconfiguration connection reconfiguration command, it has NCC set to 3, and if the access stratum algorithms are changing, it has those also provided in this RRC connection reconfiguration. Now this will take its usual path and go through the target MME to the source MME, and from the source MME to the source eNode B, and from the source eNode B to the UE. And this time it is encrypted and integrity protected by the key that has being used between the UE and the source eNode B. So this is using K eNode B, which is the one that has been used between the UE and the source eNode B in the access stratum. And just like we had in the previous case, we have, based on when this NCC comes over to the mobile, it goes ahead and knows that this is previously it had NCC2, vertical key generation, goes ahead, creates NH3 based on KSME, and then we'll use NH3 to create the K eNode B star, which is exactly the same as what the target E node B has computed, right? So, and that's what's going to be used between them. And now comes in the case of the PDC, and it'll detach from the old cell to sync to the new cell. But also we have the scenario within the network of providing the uplink and downlink PDCP count for those bearers that are data radio bearers that are using RLC acknowledge mode. But instead of going directly between the source E node B and the target, it goes via this entire convoluted call flow via the MME to the target MME and back to the target E node B. This is all because we don't have an X2 interface. So now it has all the PDCP counts for those bearers for which the PDCP counts should be continued on as opposed to being reset. So we have all of this. We have this, the UE is ready to kind of show up at the target cell, and it has been provided the security keys and also information that would enable the UE to do a much more efficient random access procedure, which is what it would do next, which is where we cover in the next slide. So it does this more efficient random access procedure, and it sends an RRC connection complete, which is encrypted and integrity protected using the new key that is using with the target E node B, and also the access stratum keys that are to be the access stratum algorithms that are to be used. And based on this, the target E node B goes ahead and tells the target MME, hey, the mobile has shown up, everything has gone well, I have received the mobile, please tell the source MME to go ahead and clean up resources on that side, so everything is hunky-dory. So, but before the MME goes ahead and cleans up the resources, it just starts a timer. It says, hey, you never know, handovers are not always successful, ping pongs happen, so I won't clean up the resources, I'll start some timer to clean up the resources. And in the meantime, the target MME will go ahead and tell the serving gateway that, hey, I am the new MME serving this UE. So the GTPC connection is now between the serving gateway and the target MME instead of the source MME. Also, it has provided the downlink TEID for the GTPU over here, and so now the GTPU tunnel is from the source, from the serving gateway to the target E node B. So now we've got the plumbing pretty much in place. The handover is very much complete, but there is one more part which is there, which is the tracking area update. Since the UE has moved into a new tracking area, it goes ahead and must do a tracking area update that it sends through the target E node B to the target MME, saying, hey, this is a tracking area update. And with the tracking area update, the target MME goes ahead and registers itself in the HSS, saying, hey, I am now the MME serving this UE. So the HSS provides the subscription data to it, and this is used for authorization. So in case the UE later wants to create, or whether the UE is allowed to create an IMS connection or not, would be all part of this subscription data. And before it sends the ACK to the target MME, the HSS goes ahead and tells the source MME, hey, you are no longer taking care of this UE. There is a cancel location. So the new MME has taken over and have provided it the subscription information. The target MME generates a new GUTI, the new temporary identity, and as we had looked in the previous slide, part of the temporary identity is actually the identity of the MME first, and then it has the mTIMZ there, which is the index of the context inside the target MME. So the first part is the ID of the MME itself. And this new GUTI is provided to the UE along with the tracking area to which it has been admitted, and any other tracking area. This can be a tracking area list. So when we look at the privacy protection. So every time you go into a tracking area, the GUI does change, and that way even the temporary identity is being updated, and that goes back to the UE as a tracking area update accept. And in the meantime, the timer that had been started in step 22 expires, and the source MME cleans up everything at the source eNode B. And so this completes an S1 handover. Now we saw there are many more steps in this as opposed to an X2 handover, which is a lot more optimized, but in case you don't have an X2, you end up with an S1. From the UE side, though, the messages are very similar between X2. The messages between the UE and the network are very similar between X2 and S1 handover. And we also covered quite a bit of the security aspects.